All right, hey folks, we're out here with Sprite again, doing some more hop tests. We're going to 1 meter for about a minute. The minute is determined based on the mission elapsed timer, which you will see in the top right of your screen. That's the MET colon piece of data there, and once it hits 60, you'll see Sprite shift into the descent stage. We're gonna try to hover at 1 meter without translating, moving, having any speed in any direction. And that's about all. So I've got some cameras set up. We should be ready for a hop test. Let's see how it does. All right, 1 meter, 1 minute in 5, 4, 3, 2, 1. All right, not bad. Okay, now we're doing a 2 meter divert flight. We're gonna go up 1 meter, hover for 10 seconds. We're gonna go over positive on the y-axis. This is local to the craft. We're going over 2 meters, positive on the y-axis. That's gonna take place over the course of 4 seconds. We're gonna hover here at that 2 meter deviation on the y-axis for 10 seconds. Then we're gonna do that same divert in reverse. We're gonna come back to this center point, which I've marked with blue tape. We're gonna hover for 10 seconds and we're gonna drop down to the ground. Each of these diverts is sort of live path planned on the craft, which means that I tell Sprite where I want it to go in the software, and then Sprite figures out how to get there. Now that's really easy. It's just a linear thing where you interpolate the velocity over time based on where you wanna go and how fast you wanna get there. But the functionality allows for a couple of cool things, which are maximum speed. You know, we can't realistically go like 80 miles per hour in one direction. So there are speed limits and a few other limits set in there that keep things safe for the craft. So anyway, let's just try it now. We're doing a 2 meter divert at 1 meter up on the y-axis, back, landing, cross your fingers. Okay, here we go. This is the 2 meter divert on the y-axis, and we're all set to go. Wind feels okay. Everything looks all right. Here we go. Good luck, Sprite. Go that way now. And now down. Nice, very nice. Okay. All right, not too bad. Let's do more. Okay, this is a 4 meter divert on the y-axis, and it's happening at 2 meters above the ground. So the craft is gonna ascend to 2 meters, hang there for 2 seconds, divert 4 meters on the y-axis over the course of 4 seconds, and then it's gonna come back down to the ground. We are currently exceeding the max speed set on the craft. 4 meters in 4 seconds is 1 meter per second. The max speed set is 0.5 meters. So the path planning function should recognize this in flight and slow us down to an 0.5 meter per second divert. And then the same goes for diverting back to the launch site, which is also the landing site. I think that's all. Good luck, Sprite. Starting to get higher with these altitudes. 2 meters is higher than we've gone before. So here we go. Okay, we are all set to go. This is the 4 meter divert at 2 meters up. Good luck, Sprite. Cross your fingers. Auto launch in 3, 2, 1. Wow. All right. That was great. That was great. That was incredible. Okay, 3-meter hop and divert in 3, 2, 1, launch. Cut. Oh, geez. This is so cool. Oh. All right, folks, it's the last test of the day here. You can see things are getting pretty dark. We're doing this because I want one more shot with the UAV. I want to get some nice shots from the air that are better than just circling the craft. So I'm going to be manually piloting that while I'm right near ground control, just in case anything goes wrong. So that's it. Here we go. All right, here we go. 3-meter hop with a 4-meter divert. Auto launch in 3, 2, 1. So that's all the testing that I did for February 25th. You can actually tell which date we're testing on by looking at the top right-hand corner of the mission control software. But I do have some more footage, and so we'll look at that before we talk about some updates for Sprite. The next bit of footage is from a very windy day. This is actually the day before, so it's February 24th. I was able to run just a few tests before I got low on power and the winds picked up to a level that was just not acceptable. You'll probably be able to tell that it was a good idea to stop testing after seeing some of the footage. We're going up to 0.7 meters with a state shift at 17 seconds mission elapsed time. Back to the descending state, just hovering. We have wind coming from, I don't know the cardinal directions here, but from the primary camera view, the wind is coming from the right and going a little bit toward the camera, about 45 degrees. So we should expect to see a little bit of motion toward the camera and to the left. That's what we're looking at. And so it feels like the wind is sort of died down. We'll go ahead and give this a shot here. Launch site is set, and here we go. Okay, next up, I did a 40-second hover with still a good bit of wind. Okay, wind feels good, so we are just about ready to go here. Auto launch in 3, 2, 1. You'll notice that the craft is placed to your right in the frame. That's intentional. We've still got wind coming from this side of the frame, moving this way. It's pretty in plane with the camera at this point rather. It was coming toward the camera before, but at this point it's just side to side in relation to what you can see there. I expect that the craft will deviate a little bit, and we'll just have to see how that works. I've jacked up the position gains, so we're going to be correcting a little harder against the wind, but because we don't have an integral term in the controller right now, there is going to be steady state error, which is why I expect the craft never to return to the home position, but rather just hold some position, maybe close to the middle. This is a pretty big guess here. I'm going to get the UAV up in the air and we'll get started. All right, we're looking pretty good here. Position and velocity uncertainties are pretty low. UAV is up in the air, so we're set to go. All right, wind is pretty low. We're just gonna go for it. Auto launch in 3, 2, 1. Okay, so it's pretty hard for the craft to fight the wind. We're getting a couple of big gusts here. Still looks all right though. Really smooth. It looks okay. Doesn't look like we have too much oscillation. It's very literally sprightly. Some of the movements look a little aggressive, but I think that's okay. I mean, I would prefer it to the craft going downrange in the wind. Should be coming close to landing now. Here we go, here's landing. Oh, boy, that landing is so hard. I think we just need to drop from higher and accept our fate as not being able to land super smoothly, especially in the wind. You know, without wind it's really okay, but it's a lot harder with the wind there, as you can see. All right, that's all I've got for test footage. Now let's talk updates for Sprite. I am coming to you live from my desk with a bunch of tea, a cold, and like 128 ounces of Dayquil coursing through my veins. So I'm doing really well. The first update is those beautiful thrust vector control vanes. They are now made out of aluminum, and they were machined really generously by Jonathan Boggs of Triaxis. I will link all sorts of details to him in the description down below. Previously, these vanes were made of PLA or polylactic acid, and this was intentionally just a stand-in so that we could get hopping and flying without needing, a bunch of precision machining. Originally, I had intended to machine these vanes myself, but when Jonathan stepped in with an email saying that he'd be happy to do it for free, I couldn't turn it down, and I knew he would do a way better job than I would. He also documented the whole process with a bunch of footage and explanation on his personal channel. I will link that down below. And that's the thing he said he wanted in return, was just to get started with his YouTube career. So please go give him a follow or check him out, subscribe to his channel, and show him some love. The next thing on the list of updates is Sprite's afterburner, which is unfortunately gone. Even after lots of iteration and a bunch of modifications, a bunch of testing, and like 2 or 3 weeks of cumulative work, I could not get the flame to stay lit or combustion to basically continue past 40% throttle on the fan. Now, here's the thing, there are totally ways to make this work, and I'm sure that with enough time and enough testing, I could get the afterburner to hold a flame at 100% throttle and do what we needed it to do. Except that's the thing, it never needed to do anything. The afterburner was a purely aesthetic choice that I wanted just because I wanted some cool photos and cool videos of Sprite. But the primary purpose of Sprite as a project was for me to get better at guidance, navigation, and control, to write some new software for the rockets that I build, and to just have a better test platform that I can fly multiple times in a day. That goal has been and still is being totally accomplished for Sprite. In fact, I'm using a lot of the lessons that I've learned on Sprite for the next rocket, Sprint, which is weirdly closely named. The point being here that while I'm sure I could have gotten it to work, and you can flood the comments with suggestions if you want, I'm not going to take any of them. It was a matter of time and effort, and it was just time that I kill the afterburner. I did, however, roast marshmallows with it. Okay, we've got the marshmallow under the vehicle, and I'm gonna start the whole process with the ground control software on my computer. Here we go. Time to roast.
too bad. We got a toasty boy right here. But here's the deal. As I open this marshmallow up, it looks like the middle of it really didn't get the roast, kind of like the outside did. I have to say, I would be disappointed eating this. Well, especially now that it's touched the concrete floor.
All right, next up on the list of updates for Sprite, I upgraded from an 8S to a 9S. Setup for the main fan battery. So I had two 4S batteries, one on either side to sort of balance out the craft. And that just wasn't providing enough power through the whole, how do you say this? Lithium polymer batteries have a non-linear drain curve, which means that when you have a full battery and when you have an empty battery, it's not a straight line in between there. You don't just go down like that. The drain curve for these batteries usually looks something like this. You start off at the top, and then you sort of go down to a plateau where you very gradually decrease as you pull load from the battery. And then once you get down near that dangerous low voltage level, it starts to really drop off, and that's where you can do some serious damage to your batteries. The point is that an 8S setup was just not giving me enough hover time. I was essentially only able to hover at that sort of peak there around the beginning of the battery's life. And so by switching to a 9S setup, even when we start to drain the battery a little bit, we end up in that sweet spot where we have a long plateau. And even though I'm doing flights that are only lasting about a minute in this video, it does seem like we could probably hit at least 2 minutes with a 9S LiPo setup. The next update is that I ditched a ton of bulk from the craft. At the beginning of any engineering project, you usually start off by designing something super fancy that looks incredible and it functions really well and it does everything that it needs to, but at least in my case, I over-engineered the crap out of it. There were fancy 3D printed mounts for the ESC and the batteries, and I had this little switchboard on there. All of that stuff looked really cool and unsurprisingly also added a bunch of weight. I had a sort of late night angry tweet about this recently, but as it turns out, zip ties are just way lighter in general and way easier to work with. And they don't require you to like spend 1 billion hours in CAD. All right, anyway. Speaking of CAD though, I did add one part that helped a whole lot. So I added more stators to the fan. A stator is a static fin that goes in the airflow, at least in this case. And the reason I added them is because the roll torque from this fan, we don't have two counter-rotating fans, we just have one. So there's a lot of torque from that motor trying to spin this fan with its air resistance and all the things that go on with it. So I added 4 extra stators that sort of counteract that roll. What we had going on before was all of the roll torques being dealt with by the thrust vector control vanes. It worked, it was kind of okay. However, the problem was, and you can absolutely see the differences between different hops, especially earlier on, the hops look really, really rough. But we were getting really close to the stall point. Each one of these fins has a point at which it stalls and it can't provide any more torque. But when we canted the fin enough to resist those roll torques, when we canted that TVC vane enough, we were reaching the stall point. And it was letting the craft just, spin out of control, basically. So adding those stators in there allows those thrust vector control vanes, you can see it in this whole video, it allows them to be nearly straight up and down, which allows us for tons of control authority during flight, much more than we would have if we were resisting the roll only with those thrust vector control vanes and not the stators, which exist above. Okay, and that's about it for the updates. Just to sort of lay it all out here, Sprite is not done by any means. I actually have a couple more things that I want to do. In the near future, I'd like to do some more higher altitude stuff, relatively speaking, so 10 meters, 30 meters, stuff like that. But it's really time to get back to doing rockets. I've accomplished what I wanted to, at least at a basic level with Sprite, which is learn some state-space feedback control stuff and just get more familiar and revamp all of my flight software. That stuff is done. I will be talking about that a lot. I've actually got a presentation at the National Rocketry Conference coming up, and I'll be discussing that a bunch. But it's time to get back to rockets. So I had a huge order from Apogee, just came in this week. I've got another big one from Aerotech of long burn G8s, G11s, and H13s coming in soon. And Sprint is the next thing on the chopping block. So Sprint is built for speed. Sprint is built for much better, much more smooth control. And hopefully, if I've done my math and I've done my homework, it'll work pretty well. But that's all from me for now. Thank you all for watching. Now, this is a longer video, but figured I should just dump all of the test footage and move on. So my name's Joe Barnard. May your skies be blue and your winds be low.